To whet your appetite for the content that's coming throughout the rest of this course, I want to do a quick whirlwind tour over the various topics that we're going to cover, touching just a little bit on each one of them. So let's start with computer hardware. What's different between a desktop and a server environment? Well, in a desktop, we typically have one CPU with 4 to 8 cores, though recently we've seen CPUs in the desktop world with core counts as high as 16 cores. Well, in the server world, we're likely to encounter systems that don't just have one CPU, but actually have 2 or 4 CPUs in a single case as part of one computer. Each of those CPUs can have up to 64 cores with symmetric multi-threading or hyper-threading, which would take us to 128 cores per socket with multiple sockets in the CPU. Another difference is going to be memory. Again, on the desktop side of things, we typically have between 8, 16, maybe 32 gigabytes in a desktop computer system, though some of them can have 64 or 128 gigabytes. That's rare. On the server side of things, we'll often find servers that have 64 gigabytes, 128 gigabytes of memory, or more. Servers are capable of handling up to 1.5 terabytes of memory. Not storage, memory. Talking about storage, on the desktop computer side, typically we have a single drive, whether that's an M.2 SSD or a spinning mechanical hard drive, or perhaps a combination of two. On the server side, however, we're likely to have several more disks. It's common to find 8 or more hard drives or SSDs in a single system on a server, typically using RAID or some other software-defined distributed file system to use those disks for both redundancy and performance. Another difference is the form factor. On the desktop side, we typically have form factors such as mini ITX, micro ATX, or full-size ATX. On the server side, while those form factors still exist, they're usually not using the same cases that desktop computers would use. Instead, they use rack mount cases or blades, and they have a variety of additional form factors, including extended ATX and some proprietary form factors for specific companies and specific server sizes. Another big difference between our desktop systems and our server systems is going to be redundancy. Now, we mentioned that server systems will oftentimes have more disk drives than our desktop systems for the sake of performance and redundancy. The idea being that if a drive dies, that server still needs to function until that drive can be replaced. Where on a desktop system, if a drive fails, typically we shut that system down, repair it, and start it back up. Another example of redundancy is going to be redundant power supplies. While a desktop computer typically only has one power supply, in a server environment, because we're going for that stability and uptime, we may put 2 or more power supplies in a system so that if one fails, the system can still operate. Okay, let's talk operating systems next. So much like in the desktop world where we have Windows 10 and various distributions of Linux and Mac OS, we have similar operating system choices in the server world. Microsoft has an operating system called Windows Server, the most recent version being 2019. It's very similar to Windows 10, but it's designed and optimized for server systems. Similarly, many of the desktop Linux distributions also have server versions of their operating system that can be used for that 24/7 stability. These server operating systems are designed to perform better in server environments than a desktop operating system would. Part of that is the patches and updates that are applied to those particular systems. Some of the features that are available in desktop operating systems are removed because they're not necessary in server environments, making a lighter weight operating system. These operating systems on the server side are also equipped with many of the roles and features, the services that a server needs to offer, which are not required or desirable on the desktop side. From a networking perspective, servers can be vastly different from desktops. As we've already seen in the hardware and OS categories, servers are going to differ from desktops in the number of Ethernet ports that they have and the number of IP addresses that are assigned to them. While a desktop computer might have a single Ethernet port, or at most 2 Ethernet ports and maybe a wireless connection, Servers frequently have a minimum of 2 Ethernet connections, and it's not uncommon to find 4 or 6 Ethernet ports on a server. Similarly, a desktop will typically get 1 IP address, but a server offering multiple services or hosting many virtual machines may actually have several IP addresses all on the same machine. While most desktops use gigabit Ethernet, most servers have graduated to 10 gigabit Ethernet or fiber, as the bandwidth demands on a server can be significantly higher than the bandwidth demands on a desktop. I mentioned wireless on the desktop side. It's very rare, but not impossible, for the server side to have wireless, because wireless is inherently unreliable. And if it is in fact a server that we're relying on for uptime, stability, and performance, wireless is not going to be our first choice. Also, because servers are typically stationary, it's easier to run cables than to utilize wireless in a server environment. When it comes to security, both desktops and servers are going to be significantly hardened to protect them from the variety of threats that are out there today. However, with servers, we have a much more complicated environment because there are services that we want to offer out to other devices. And every single one of those servers brings with it its own new set of vulnerabilities. Because of that, our hardening of the operating system or division of resources is going to be significantly more difficult than the hardening of a desktop computer system. However, the process of risk management, where we do threat modeling and risk analysis, is going to be very similar to our desktop world with our server world. We're still going to put measures in place to reduce the probability and impact of a variety of threats, but our tools may be different for doing that. Lastly, disaster recovery. In a desktop environment, disaster recovery oftentimes involves replacing the unit outright, throwing away the old, bringing in the new, and setting things back up. In the server world, because of the cost of the equipment and the intricacy of the configuration, throwing it out and starting over is not always an option. So our preventative measures preparing for those disasters, as well as our reactive measures of how we respond to those sorts of threats, will be significantly different in the server world than it will be in the desktop world. Alright, so that was just a quick overview of some of the topics that we're going to discuss throughout this class. I hope that it's created some excitement in you about these topics, that you're looking forward to hearing more about them, and maybe it's even got your wheels turning on how you would solve some of the problems presented, or maybe utilize some of the performance advantages of servers over desktops. Anyway, thanks for watching. We'll see you in the next video. Click like and subscribe.